Now we want to look at multiplication with radical expressions. Our first problem is 2 square root 3 times 5 square root 7. Now what happens is we can multiply the numbers outside the radical and we can multiply the numbers that are inside the radical. So we will end up with 10 square root 21. The reason why is because of the commutative and associative properties of multiplication. We can rewrite this as 2 times 5 times square root 3 times square root 7. Now we don't show this step all the time, but this is the reason why we can multiply 2 and 5 and 3 and 7. 2 times 5 is 10. Square root 3 times square root 7, using property 1 for radicals, is the square root of 3 times 7, since they're both under a square root, so we get 10 square root 21. So that's what we get when we multiply these two radical expressions right here. Let's look at one where we multiply two radical expressions that have the same form as binomials. Square root 10 plus 5, square root 10 minus 3. I'm just going to multiply as if these were two binomials. Square root x times square root x will be x. Square root x times negative 3 minus 3 square root x. 5 times square root x is 5 square root x. And 5 times negative 3 will be minus 15 there. Now I have two similar radicals here, minus 3 square root x and 5 square root x, so I have x plus 2 square root x minus 15. So this is what I get when I multiply these two expressions here, and I do that multiplication just like I was multiplying binomials. Let's look at another problem. I have square root x minus 3, that quantity squared. Now that means square root x minus 3 times square root x minus 3. If you write this out this way, it'll keep you from making that mistake where you square the first term and square the last term. That would be the wrong answer, to say that this was x plus 9. We need to multiply it out just like they were binomials. So again, square root x times square root x is x for the first term. The last term, minus 3 times minus 3, which is positive 9. Inside, minus 3 square root x. Outside, minus 3 square root x. I add those, I get minus 6 square root x. So I multiply these two just as if they were binomials, just like I did the problem just before this. Multiply each term here by each term here. This is what we end up with. Let's look at one last problem here that involves division. I want to divide square root 2 by square root 6 minus square root 2. Now, what I'm going to do really is simply rationalize this denominator. Take these radicals out of the denominator by multiplying the numerator and denominator by the conjugate of the denominator, square root 6 plus square root 2. When I multiply square root 6 plus square root 2 times this, I'll end up with square root 6 squared minus square root 2 squared, and so I won't have any radicals left. If I do that multiplication to the denominator, I have to do the same thing to the numerator. Okay, so when I multiply now, in the denominator, when I multiply these two conjugates, I'm going to have 6 subtract 2. That's square root 6 squared, which is 6, minus square root 2 squared, which is 2. In the numerator, I multiply here and I get square root of 12 plus square root 2 times square root 2 will just be 2. So let's see. Square root 12 in simplified form is going to be 2 square root 3, because 12 is 4 times 3 and the square root of 4 is 2, plus 2, all divided by 6 subtract 2, which is 4. Now this expression I can reduce to lowest terms, so I'll come back over here, factor a 2 from the numerator, 2 times square root 3 plus 1, all divided by, in the denominator I'll just write the 4 as 2 times 2, so you can see that common factor 2 can be divided out, and I end up with square root 3 plus 1, all divided by 2. So there's two different kinds of instructions we can have for a problem like this. We can either say divide, so it looks like a division problem, or we can say rationalize the denominator. In either case, this is the way you would proceed, by multiplying numerator and denominator by the conjugate of the denominator.